Hey guys, welcome back to the course in which we're going to learn about coding and how to use Unity and also the Unity engine namespace. So in the last episode we did some really basic types here. We talked about the hint, we talked about the float, the bool, the string, all of these, and I'm going to just get rid of them because we're not going to be using these anymore. We're going to be looking at something else today. So we have a basic understanding of those four types. They're being used pretty much everywhere. We know that we store full numbers inside of ints. We know that we store decimal number inside of float. Boolean can only have a true or false, and string is for mostly just messages, right? So once that we know this, we're going to move on to more types. And those one are going to be specific to Unity. So what you can do is actually create types for yourself. For your actual code, you can create some types. Unity has some really useful type that we're going to be using throughout the whole tutorial and throughout the whole making of games in Unity in general. Let's just have a look at a few of those. So those are really specific to Unity. You're not going to be able to find them in other kind of C#. I'm just mentioning this here. So don't look for the following in other engines. They might have a similar representation of what we're trying to do here. They might have something really like maybe even the same exact name, but they're not the same thing in the end. So the type we're going to be looking at today are pretty much all of the components. Now I need you to understand that the components, they also have a code definition for them, such as a game object has a type called game object. It's just like a normal field that you could call my object. The transform has its own definition. Why not my transform? So these guys here are pretty much just a representation of what we see in the component on the right hand side here. So the very top hand side here would be the game object, and just beneath that we have a representation of the transform. We can have a box collider as well. If we go back in our code, we can type in box collider and it should pop. So box collider, my collider, why not? And now this is really interesting because the script that we've created, which is a component, also counts towards that. So if you go here and you type in my first script, you can also have a field called my first script. We can also have a type. So when we actually create that, we create more than just a component. We create a type that we can use. And that is something we're going to be learning as we go. So that's something you're going to be like creating nonstop. You're going to be creating your custom type to have your own logic going on. So that is something really cool. Now, how exactly do we go about knowing which one we actually use? As you can tell right here, we just declare something my object, but how does it know that we want to use like my game object? There is multiple ways to go about it. Something that you would do if you're just a little bit new, you just want to play with the inspector a little bit, if you have some designer doing the game, is you would write something like public in front of it. And this is going to make your field appear inside of the little inspector here. So as you can tell, I've turned all of my fields here into public fields, which mean they're going to appear in the inspector. So my object is right now equal to none, it's not equal to anything. My transform is equal to none as well, collider, nothing has been really defined. The way you actually define those is by clicking this little icon here and then you look for the object. Right now nothing really works here, I don't know why. The transform works, so you can assign the transform of say the camera. You could say that my transform, my value here that we've created, so this value here is equal to the transform of the camera. So it goes a little bit further, so this thing here points towards this component. You can do a lot of things here, so you just assign whatever you want. You can assign it via the little menu like I showed you, or you can drag and drop. So you could say my object is equal to cube, you just drag in here and it's going to grab the game object of cube. Now for my transform, you can do the same exact thing. So you grab cube, you put it in here, it's going to grab the transform of that cube, or you can manually just grab your component. So transform up here, you drag and drop it in the transform field. Then my collider, you can drag and drop it in collider, and my first script, you can even grab itself and put it right here. So this is one way you define the value inside of your field. You could also do that, and I didn't mention it earlier, you can also do that with basic type as well, such as public int, life count, just like this. You don't even have to assign a value. By default, it's going to assign the value 0. And then when you go back to the inspector, you should see this pop up. So life count is equal to 0, and you can manually just change it here. So when you play your game and you say like life count is equal to 5, it's going to be equivalent to this. So life count is equal to 5. but instead of doing it via the code here, we've done it via the inspector. So now let's go back to what we said earlier. So we said that we can put our component inside of fields that we can then reuse later on. So right here, public game object, my object points towards this thing here, so the cube game object, which is defined by this very top side here, the inspector. We have my transform, which right now is pointing towards cube transform, so this guy contains the position, rotation, the scale, and also more stuff beneath that we can't really see right now. Collider contains the collision mesh, which is right here, so this green box. And then we also have a reference towards my first script, which contains myself basically, so it contains all of those information. Now this is where the fun part happens, so you can modify pretty much any of those components via script as well. So let's give this a look. If we go in the start function and we type in, say, my object, which is, you know, it's the reference towards my cube object, and then you do a little dot sign, you have a lot of stuff popping up. Now right now you don't see it on my screen, but if you do it on your side, you're gonna see like a lot of information just coming up, such as function called, say, set active. You can set active to a boolean, ask me, so I'm just going to say false. So my cube object dot set active false. I'm setting my cube object to false. So when I press on play, it actually toggled off my cube, so it's no longer here. In the game I can't really see it, but in memory it's still right here. As you can see, it's still in the inspector, and I can toggle it back on by pressing on this. So basically everything that happened inside of that function call was a simple click on that button. Now I'd like you to realize that something that we are going to do most of the time can also be done via the inspector. So let's just say that in our game we want our cube to be moving on, say, the z-axis. We can do that by simply clicking here and holding, and it moves. So let's just say that this is what we want to have in the game. It's also possible to do it in the inspector. And the other way is real as well. So whatever you do in the inspector can also be done in the game. And that is very cool, because let's have a look at this. We have, say, this light here. And I'm just going to toggle on the lighting so we can see it. And on this light, if we play with the, say, the intensity, as you can tell, the little cubes here, they light up and they just, you know, they change color as well. You can do a lot of stuff. But you can also do that via code while the engine is running. Let's give this a try by grabbing the light component and just playing with the intensity in the update function. Why not? So over here, I'm going to do public light, and usually just, if you want to like spot a specific component, you simply look at the name they have, in this case light, and you just type that in. You're going to have autocomplete, and you can just play with that. So let's call this scene light, why not? And inside of the update, we're gonna go down here and say scene light dot, and then you get a lot of fields. You have to just look through it, and like I said, unfortunately you can't really see it on the video. For some reason it's not showing the little window, but I have a little window here where I can just navigate through all the information I have. Like I see, intensity is right here. So we can do intensity is equal to a float. So let's go ahead and just do intensity is equal to 0.5, something like that, which is half of the intensity we currently have. So when we press on play, it should be on 0.5, but however, it's not working. And welcome to the very first error we have in our code, the very first crash. As you can tell, our game is now paused by looking at the little sign here, and that's because our game could not run. We have an error. And this is one of the most common error that you guys will have. It is a null reference error. It means it was not able to find scene light. In this case, because I just double click on it, it says the variable scene light of my first script has not been assigned. And that is totally true. Scene light is equal to a public light here, but we never really decided which one it would be. So just say that we had multiple of those directional light, then which one exactly do we use? Do we use this one, this one, this one, or this one, right? So what we have to do is go back where my first script is assigned and just have a look at the error. Scene light is equal to none. So when we're doing none, dot intensity is equal to 0.5, well, none doesn't really exist, right? So it's not really able to assign this, and it crashes. Now what we're going to do is take our directional light, drag and drop it inside of the scene light, and this way we now have a reference. So this is the one we're modifying, and if we double click on it, it goes here. This is the one we're modifying. If we press on play, intensity is now equal to 0.5. Now let's actually play this over time. Since we're in the update, we want to see this say decrease over time. What we're going to do is say minus equal 0.5, so a really small value. So over time, it's simply going to decrease that value, as you can tell right now. And it went a little bit too fast, so we're going to try that again with another 0, why not? And then when we press play, we just have a look at this, and it gradually just gets darker and darker. And if you want to have a look at the progression of the float, you can look at the very right side here. You also have the little slider just going down slowly. And I'm going to just bring my camera just up close so we can actually have a look at this very close. And there we go. So as the time progresses, we have less light, and it just looks like that. We can also modify, say, the field of view of the camera. Just change that a little bit if you wish. There is a lot of things that you can play with. So everything that you see in the inspector is something that you could potentially just mess around with, including the transform component, and that is something we're going to be using quite a lot in the next episode. But let me just give you a glimpse of what we can do. So we have a reference towards my transform, which is the transform of my cube, the one that has the object on it. We can do my transform dot position, and then I'll just play around with a vector 3 and forward. Now we'll explain this in the next episode, but I'm just going to show you what this does right now. I'm putting that in the update, so every single update, it does a plus equal of the position of my cube, moving it in a forward direction. So we have a movement going on, as you can tell. Alright, so let's go back quickly to our code now. We have all of these values on public, but it's really messy. It's really not that good looking. Usually you don't like to have so much public values, and I'm just going to remove all of them. But now the result we get at this point is that we're not really able to assign them anymore. Since they're not public, they're not being put in my inspector, and when I run my code, it's simply going to crash because we have no reference, and that is right because we didn't drag anything in there. We can't drag anything in there because they're not public. There is another way to get the components via code, and it's much cleaner in the inspector, and it's much cleaner in terms of code as well. So here's what we're going to be doing. We're going to be getting rid of a few of those. We're only going to be grabbing the game object and also the transform, because those are components that are part of my cube right now. So my cube contains a game object, a transform, a box collider, a mesh filter, a mesh render, but also my first script. We could keep my first script if you wish, and just type in my script, but we're not going to be using it too much. Now, the way we actually get those components on top of my object, and this only works for your current object you're on, is by typing in get component. And this one is a little bit special, and I'll show you exactly how you do this. So first you look for which field are you trying to fill right now. So which of these value are you trying to fill? Let's go with the game object first. So my object, that's a game object by default, is equal to get component, and then you do the type. So which type of component are you trying to get? In this case, game object, which is always, you know, if my object is a game object, then you pretty much just want to grab the type of that value. Now next one would be transform. So my transform in this case is equal to get component transform, and that is going to work. And finally, my script is equal to get component my first script, just like this. So it's actually using the type, right? Now this is not going to work if, say, you're trying to get the light, because the light was on another object. So you have to do one more step, which I'm not going to show you right now because we're just getting started here. And you have to do just an additional step. That's not going to work unless the component is on the object you're calling it from. So right now my first script is on the cube. You're only able to access stuff that is on the cube. And a little bit later on we'll see how to move away from that cube, move on another object. But let's just start with a really basic stuff like that. And now our script should work because in the update we're using my transform, and my transform is equal to the component on top of my cube. So this is my cube. My transform is equal to get component transform, in this case this guy, and we just press play again. It's back to actually working. We also have a reference towards the game object if we want to modify some stuff in there. Okay, so now that we understand that we're able to get component on our object and a little bit later on also other objects, get a reference to those and modify value manually, once we understand that, we can now move on to the next step. Next step is going to be about moving the transform component. And the reason I'm not doing this right here in the same exact episode is because the transform component is going to introduce a new type of field again, so a new type of variable, and that one is going to be the vector3, which we use down here, but we didn't really explain it, so we're going to go back to explaining this and actually just moving a transform around, maybe playing with a little bit of maths. We can do a lot of stuff, so that is going to be for the next episode. Please leave a like on the video if this did help you, and please check out the Patreon page if you wish to support this course, and also the future course we're going to have on the N3K channel. So guys, again, leave a comment if you have any question, please like the video, and subscribe for more. I'll see you guys next time.